Right, apparently I missed out question 16 from exercise 4.3. Right, so I'm going to do it here. Not to worry, I don't think it is too unmanageable. Let's look at the questions. So you're given f of x is exactly divisible by these two linear factors here. So when something is exactly divisible by another thing, it means that the remainder is 0, right? Using factor theorem. That means what we are saying, it's x minus 2, x plus 1 are factors of f of x. All right, so let's rewrite the expression to be x to the power 4 plus ax to the power 3 minus x squared minus 12. So this dividend will be equals to your divisor multiplied by your quotient, and because fx is exactly divisible by x minus 2 and x plus 1, therefore the remainder is 0, so plus 0, but there's really no need to put plus 0. Okay, so there are two unknowns here we have to find, a and b. So this is something similar to what we have done in the subtopic solving identity, finding unknowns in identity. We can use substitutions to get rid of your q of x. So if you were to examine the two linear factors, we can look at the first linear factors first. Okay, if you let your first linear factors to be equals to 0, you'll get x equals to 2, right? So when we sub x equals to 2 to the above, you will realize, you observe that right hand side will give you 0, because x minus 2 is 0. 0 times anything will just give you 0. Then the left hand side we need to substitute 2 into the x. Alright, so that simplified it. So this one here and this you can just use your calculator to work this out. Right, so you will get 0. So you will have 8a plus 2b equals to 0. So we call this equation, or you can divide by 2 to get 4a plus b equals to 0. So we're going to call this equation 1. Okay, so we're going to form another equation. So in this case here, we're going to look at the second linear factor. So we're going to let the second linear factor equals to 0. So x will be negative 1. So we're going to substitute x equals to negative 1 to the above, so that we can generate another equation involving a and b. We will have negative 1 to the power 4 plus a, negative 1 to the power 3 minus negative 1 squared plus b, negative 1 minus 12 equals right hand side 0. Likewise, this one and this, you can just use a calculator to work this out. Right, so you have negative a minus b equals to 12. Right, so we call this equation 2. So I'm going to just use the elimination method. So take equation 1 plus equation 2. I would have 4a plus b plus bracket negative a minus b, 0 plus 12. That will give us 4a minus 4a plus b minus a minus b equals to 12. That will give us 3a equals to 12, and so a is equals to 4. And then you can just substitute a equals to 4 into equation 1, and you will have b equals to negative 16. Right, so from part I, we managed to find a equals to 4 and b equals to negative 16. And we're going to substitute both these unknowns into our f of x. to get x to the power of 4 plus 4x cubed minus x squared minus 16x minus 12. And then we're going to expand the your quadratic factors, right, to get x squared minus x minus 2. So I need to solve the equations, means I need to find the remaining factors. There are two ways of doing it. You can either use long division, or you can use compare coefficients of similar terms. So I'm just going to show you both methods. So first method I'm going to show you is using long division. Right, so if you were to recall, using long division, just take the first term of your dividend, divide by the first term of your divisor. So that will give you x squared. X to the power 4 divided by x to the power 2 means x to the power 4 minus 2, give you x squared. Right, and then you take your x squared times x to the power of 2 times every term. So you end up getting x to the power of, use the same color, x to the power of 4 minus x cubed minus 2x squared. Right, and then you take your dividend to minus away, x to the power of 4, you will get end up getting 5x to the power of 3 plus x squared. All right, minus 16x minus 12. So this becomes your new dividend. So you repeat the process. Take the first terms of your new dividend, divide by the first term of your divisor. So 5x cubed divided by x squared will give you positive 5x. Right, so you multiply back again. All right, so you take the old dividend minus away. 5x cubed minus 5x squared minus 10x. Then you end up getting 6x squared minus 6x minus 12. Right, so taking your new dividend again, 6x squared divided by x squared will give you positive 6. Right, and then you get remainder 0. You have to get remainder 0. If not, then there's something wrong with your long division. So therefore, we will have x squared minus x minus 2 times x squared plus 5x plus 6 equals to 0. We're solving it. Okay, solve fx equals to 0. That means you need to find the values of x that satisfy the equations. So this one here, this is where is the expanded form of these two linear factors, x minus 2 and x plus 1. This, you can use your calculator to help you factorize it. Give it x plus 3 and x plus 2. Right, so using your AB product rule, it means that x minus 2 can be equal to 0, or x plus 1 equals to 0, or x plus 3 equals to 0, or x plus 2 equals to 0. So therefore, your answer, possible answer for x will be 2, negative 1, negative 3, or negative 2. Right, so this is how you solve it using long division. The next slide, I will show you how you use it, how you use compare coefficients of similar terms to do it. Okay, so I'm going to show you alternative methods to solving this, to finding the remaining factors rather than using long division. Okay, so this method I'm going to show you is to compare coefficients of similar terms on both sides. Let's start off by writing your dividend. This is your dividend. Is equals to your divisor, which is x squared minus x minus 2. Right. Now, the highest power here, you can see, is of degree 4. This one is of degree 4. And this is of degree 2. Right, so I need to multiply also with a degree 2. So to get back my degree 4, because 2 plus 2 then give me 4, right? So what is a polynomial of degree 2? What is a polynomial of degree 2? Yes, it's your quadratic polynomial. The quadratic polynomial is of degree 2. So I need to multiply your divisor with a quadratic polynomial. Okay, this is not new. We have already done this before. To find the first term, that's relatively easy. This is just ax to the power 4 give you x to the power 4. Alright, the ax to the power 4 on the right is equals to the x to the power 4 on the left. So divide by x to the power 4 on both sides, a is 1. And then your constant term times your constant term here, which is negative 2c, will gives you your constant term here, negative 12. So c will be 6. Right. Excuse me. So we're going to put this back into our identity, which will give us x to the power 2 plus bx plus 6. Right, so what we need to find next is to find this unknown b. Right, so this is also not new. We've done this before. You are in a very good position because you can actually compare x cubed term, x squared term, or x term. Just choose one of them. So I'm going to compare my x term. So on the left hand side is 16, negative 16x, negative. Make sure you include the negative. Right, so I need to fish out my x term. So I'm going to take this times this times this. Okay, all this doesn't give me my x term, so I can forget it. Then go back to your second term of your quadratic divisor. Multiply. Okay, the last one is the one I'm interested in. Then go back again, because altogether you have three terms here. X squared, negative x, negative 2. So you have to do it for all. Negative 2bx. Alright, so we divide by x throughout. So negative 16 is equals to negative 6 minus 2bx. 2b. So negative 2b will be negative 16 plus 6. That gives you negative 10. So b will be 5. Okay, so therefore, I'm going to put everything back again. So therefore, what you have is x squared minus x minus 2 times x squared plus 5x plus 6 equals to 0. So if you factorize, you will get this in x minus 2, x plus 1, and this one will be x plus 3, x plus 2 equal to 0. Okay, so you apply the AB product rule, you solve it, you will get the same answer, which is what we got earlier on, x equals to 2, negative 1, negative 3, or negative 2. So you can choose whichever method you want to use to solve this unknown, to find the remaining, basically here I think this is a quotient, this one is a quotient, or your remaining factors. Okay.